Now, we just did how meiosis segregates chromosomes and alleles for a single chromosome or a single pair of alleles. But what we want to further on sort of discuss is what happens when there are two alleles. Now, in this particular case, we're going to do it in the case of two different chromosomes, so they segregate independently from one another. So again, we have mom, okay, and we have dad's sperm, okay, and now in this particular case, we're going to have one chromosome that has big A on it and another chromosome that has little, big B on it, okay, and likewise, two chromosomes here, little a, another chromosome, little b. Okay, so these unite, they form a single diploid individual with this particular genotype. You can write it as big A, little a, semicolon indicating a different chromosome, big B, little b, but we can also demonstrate it with the chromosomes themselves. So in this particular case, big A here, and then little a here, and on a different chromosome, big B here, and little b here. Okay, so in this particular case, we're going to march through meiosis, all right? So I'm actually going to re-erase that and give you a bigger, zoomed in look. So, now the important thing to understand is, again, as usual, first you replicate your chromosomes. So you're going to go through S phase. So big A, mom's chromosomes. Replicate big B, and then you have dad's chromosomes that have also replicated. The sister chromatids, little a, and little b. Okay. Now, notice I've done this in one particular orientation. Okay. So if we were to just follow Meiosis2 in this particular orientation, where these sets of chromosomes are lined up, where dad's chromosomes are lined up on one side and mom's lined up on the other side, well, again, as usual, those will segregate away from each other, okay, in Meiosis1, M1, okay, and you get your products that look like this. Chromosomes from mom to one side, and then chromosomes to dad to another side. Okay, and in this particular case you have big A on this chromosome, big B on that pair of chromatids, and then conversely little a, little b. Now you undergo M2. This is like the mitotic division. This is called the reductional division at first, and then go through what is like a mitotic division in M2, and the centromeres split. Okay, and you're going to end up in this particular case with 4 gametes as before. Okay, with 2 haploid sets. Okay, and that will be identical. Big A, big B, big A, big B, and then little a, little b, little a, little b. Okay. So half the time you'll produce gametes like this in this particular way of segregation, and the other half the time you'll produce gametes like this. So 1/2 and 1/2. But those aren't the only sets of gametes you can produce, because just because we show that these chromosomes are segregating in this particular fashion, you can have an alternate mode of segregation in which the paternal or the maternal chromosomes do not segregate together. So in particular, you can have a scenario like this, in which this little b segregates with that big A, like that, okay? And then you can have, of course, go this way. You know, this will produce a different set, okay? This will produce a set in which the maternal and paternal chromosomes are segregated separately from one another. Okay, so in the first scenario, you're still going to have big A, okay? But now the chromosomes are like this, little b, okay? And then correspondingly, little a, okay? And then big B, and then big B, okay? Now what's important here is that the segregation of this one is independent of the segregation of that one, okay? So you can think of the total outcome of the gametes as being like this. So it's going to be the alternate way that way. And so you can consider at a Mendelian level 4 possible gametes, okay? One is the ones that we were talking about, which are like the ones that were inherited from the mom here or the dad here. But these alleles segregate independently from the way that these alleles segregate, okay? So you can also get this pattern, big A, little b, okay, and little a and big B. Okay, now what is the proportion of each of these types of gametes? Okay, in the first scenario we were showing these types of gametes coming out. This is half the time, but that was under scenario 1. Okay, this is under scenario 2, in which they segregate separately from one another. Okay, well, scenario 1 can happen half the time, okay, and scenario 2 can happen half the time, okay, and for scenario 1, half the time you're going to get this, or half the time you're going to get this, okay, so you can multiply these together. Same with here, half the time you're going to get this if you condition that scenario 2 has happened, or half the time you get this. So what this gives you is 1/4, 1/4, 1/4, and 1/4. So an individual that has these chromosomes and alleles in this arrangement will produce these particular types of gametes in equal frequency. Okay. Now, there's another way of thinking about this, and I'm going to outline this to allow you to imagine more complicated scenarios in which we have more than 2 loci. Okay. Well, you can kind of think of these as independent events. So the probability that you inherit big A or little a, right? Probability of that, forgetting about the B allele, B locus, okay, is equal to 1/2, right? Okay. And then forgetting about the A and just considering B, the probability that you get the B allele, okay, is equal to 1/2. The probability that, forgetting about the A locus, the little b allele is equal to 1/2. Right? So since these are independent probabilities, the probability that an individual ends up inheriting this particular gamete from their mom is 1/2 times 1/2, or the probability that they inherit this particular gamete from their dad is 1/2 times 1/2, for example. So it's 1/2 times 1/2, so the probability of getting this is equal to 1/2 times 1/2, okay, which is equal to 1/4. Okay, the probability of getting little a little b is equal to 1/2 times 1/2, which is equal to 1/4. Okay, and you can then, of course, imagine the other types of gametes. For example, big A, little b is equal to 1/2 times 1/2, which is equal to 1/4. And you can see how this comes out of meiosis, in which these chromosomes segregate independently of one another, give us basically independent probabilities. So the probability of gametes that coming out of a particular individual are just determined by the multiplication of the probabilities for inheriting any particular of those 2 different